Hello everyone, I am back with one more tutorial today, and today's tutorial is about class 9 ICSE chapter 1 for maths, that is rational and irrational numbers. Previously I think I had recorded a video for exercise 1.3 and 1.4, but I got to know from a number of students that they are having certain doubts for exercise 1.2, right? So where most of the questions are like, you prove that root over 1 or root over 2, root over 5, those are irrational numbers. So in this tutorial I'm going to discuss on how do we prove that root over 5 is an irrational number, or root over 7 is an irrational number. So in case if any background noise is coming, please ignore. I'm trying best to give a perfect recording of this tutorial today. Okay, so it is exercise 1.2, chapter 1, class 9. The sums that I'm going to see is from the ML Agarwal book. In case it differs, whatever I will be recording, I'm sure it is going to help you out with whichever book you follow, whether, because the questions are more or less the same, right? So question number 1, I don't have my book right now while I'm recording this, so I'm using my phone where the questions are there. So I'm using the phone to see the questions. Okay, so the first question that I can see is question number 1. It says proof that root over 5 is an irrational number. Question is proof that root 5 is an irrational number. Okay, so in order to prove this, first thing that we assume, if you have done the first exercise, you will understand that we have to assume that root 5 is a rational number. Let us consider. So let us consider that root 5 is a rational number, because we have to prove it is irrational. So let us see if it is really rational. But when I'm writing that it is a rational number, we have to recollect the definition of a rational number. Now, what is the definition of a rational number? Rational number means it can be denoted in the form of p by q, where q is not equals to 0, right? It can be written in the form of p by q, where p and q are integers and q is not equal to 0. So if the first statement that we have written is, let us consider it is a rational number, so we can simply write, therefore root 5 equals to p by q. Please note here that p and q are integers. P and q are integers, and q not equal to 0. So this is as per the definition of a rational number. I have written that root 5, we are considering it as a rational number, and we are writing it in the form of p by q. Now what if I just square both sides? So I'm writing squaring both sides. The intention to do this squaring is that, you see, there is a root over here, so I just want to remove the root over. So squaring both sides, we get root over 5 whole square equals to p square by q square, right? So now we can write this as 5. Root over 5 whole square is 5, and here we can write p square by q square. So from here, can I write p square equals to 5q square? Surely we can do that. Q square, I shifted it this side, so I got it as p square equals to 5q square. Yes. Now from here we can see that p can be p5 can divide p, because from here we can simply write q square equals to p square by 5. So I can write that 5 divides p. Okay, 5 divides p, because you can write from here that q square equals to p square by 5, right? Now let us consider some value for p. Let us consider some value for p. Say let p equals to 5m. Let p equals to 5m. I'll tell you once we proceed with the sum why are we considering some values for p also. But now let us consider 5m. Here one reason for taking 5 is that we can conclude from this equation. We can conclude from the equation that 5 can actually divide p. Okay, so I'm taking p equals to 5m. Now from this equation, let us consider this as equation 1. So from equation 1 or putting the value of p on equation 1, we get that 5m whole square equals to 5q square, because I'm just putting the value of p on equation 1. Now let us see. So here I can write it as 25m square equals to 5q square. From here simply we can write 5m square equals to q square. Now if I am getting this as we got this equation 1, let this be equation 2. Please see, from equation 1 we were getting that 5 can divide p. Similarly, from equation 2 I can conclude that 5 can divide q as well, right? So implies that sign 5 divides q. 5 divides q. So now please recall the definition of rational number. Rational number can be written in the form of p and q, where both are integers and q not equal to 0. So now we can simply write that p and q have a common factor, have a common factor. What is that common factor? 5. P and Q have a common factor 5, right? And this contradicts, this contradicts that P and Q have no common factor, have no common factor other than 1, other than 1. So if we are writing any number in the form of fraction where both are integers, that is the numerator and denominator are integers, and the denominator is not equal to 0, right? So that has to be in the simplest form. But when we are seeing this, we are considering root 5 to be a rational number, and then we are observing from the two equations, equation 1 and equation 2, that p can be divided by 5, q also can be divided by 5, which means what? 5 is a common factor between p and q. So henceforth we can conclude that p and q have a common factor 5, and which contradicts the fact that they do not have any common factor. When we are writing or considering the rational number p and q, they are not supposed to have any common factor other than 1. Then only they can be in the simplest form and in the correct form of p by q, right? But here we are seeing that they are having a common factor. So henceforth we conclude, or it is contradicting the fact that they have no common factor other than 1. So henceforth we can say that root 5 cannot be expressed in the form of p by q. They cannot be expressed in the form of p by q. Why cannot they express? We cannot express because they are having a common factor. So we can simply give the conclusion, that is, it is not a rational number, or final statement, root 5 is an irrational number. Now question comes, if it is not a rational number, how can I conclude it is an irrational number? So I'm sure at the beginning of this exercise, when you have started exercise 1.1, you must have learned the definition of a rational number and as well as irrational number. And just a reminder, rational number plus irrational number brings us our real numbers. So all the real numbers include rational plus irrational. I'll take a small pause. I think I'm having difficulty with my mic. I'll adjust that and resume from number 2. So this was sum number 1. Okay. So number 1 was on your screen. Now we will move on to sum number 2. Sum number 2 is stating us, I'll just edit so that I don't need to write the whole thing again. But as students, you need to do the sum. So sum number 2 states that prove that root over 7 is an irrational number. So in order to prove that it is an irrational number, the same thing has to be repeated. I think the background noise is there. Root 7 is an irrational is a rational number. So we will consider root 7 as a rational number. Here we can write root 7 equals to p by q, where p and q are integers and q not equal to 0. So on squaring both sides, now if I square both sides, we are going to get root over 7 whole square, or here we will get 7, or p square equals to 7q square. From here I can conclude that 7 divides p. So this is our equation 1. Now since from here I can conclude that 7 divides p, we will consider the value of p to be 7m. We will take the value of p to be 7m. So 7m whole square equals to, here it will be 7q square, right? I'll, for the convenience, I'll edit this part and show you what we are getting. So from here, please see, p we are taking as 7m, and here we already have 7q square. So now on squaring the sides, means as putting the value, 7m square means I can write 49m square, and here 7q square, or I can write 7m square equals to q square. From here we can write, let this be equation 2. From here we can conclude that 7 divides 7 divides q. So p and q have a common factor. P and q have a common factor, that is 7. This contradicts that p and q have no common factor other than 1. So root over 7 is an irrational number. I hope this is clear. If still you are having doubt or you are feeling disturbance, please let me know. I will try to cut out the background noise again through some editing apps. I hope this is clear. Now like this, root over 5, root over 7, so same way they might give you root over 6. So we are going to discuss that further in the next sums. I hope this is clear. So I'll erase. Let me check the next sum if it is worth the discussion. If it is the same, yeah, as I was saying, number 3 is root over 6 is an irrational number. So I'll show you on the board in the same way. I'll make it number 3. Root over 6 is an irrational number. Again the next statement, root over 6, let us consider that it is a rational number. So root over 6 equals to p by q, where p and q are integers and q not equal to 0. Now squaring both sides, we get 6 root over whole square. We will get here 6, or we will get again here 6, and we can conclude that 6 divides p. So now we can write, let p equals to 6m, right? Let p equals to 6m. Now we can write 6m whole square. Here also 6q square. Again I will erase this line, that is we will get 36m square equals to 6q square. From here we can write 6m square equals to q square, or we can conclude that 6 divides q. So p and q have a common factor. They have a common factor, that is 6, which contradicts that p and q have no common factor other than 1. So henceforth we can say that root 6 is an irrational number. The most important place where the students often get confused is that how to prove. The means the mind goes blank, and the first statement itself vanishes from the brain when while doing such a sum. So please remember, when question comes that prove that it is an irrational number, first thing that you are going to write is first statement that let us consider root 6 is a rational number. Just the opposite. Now recall the second step. Recall the statement or the definition of a rational number, that is it can be expressed in the form p by q. So then the second step will be root 6 is p by q. Now what are p and q? They are integers and the denominator, that is q, is not equal to 0. This much done. Third step you must remember, that is removing the root over. So if you have to remove the root over, we have to square both sides. So squaring both sides we get. Now when you square both sides, you are writing it in equation form. Now when you are writing in equation form, you can see that here the number 6 is dividing p. So now let us consider one value for p. So you can take it as 6m, which will make the sum easier. You could have taken 2m, 3m, 4m, but no, if you take that, proving will be difficult. So since we are already concluding here that 6 can divide p, so let us take p as 6m. Now you put the values and you see, you can conclude that 6 can also divide q. Now if 6 is a common factor, then it is difficult, or it is difficult to express these two means digits p and q in the form of a fraction, because they are having a common factor, and which is contradicting the definition of a rational number. So finally we can conclude that it is an irrational number. So this was all for number 3 as well. I think there are total of 8 sums. So number 3 is done. Oh god, my phone started hanging. Okay, yeah. Number 4, where is number 4? I went too far. Just a moment. Yeah, number 4, the question is to prove that 1 by root over 11 is an irrational number. So I will tell you, it is the same thing. 1 by root over 11, instead of root 6 we have to put 1 by root over 11 is a rational number. Here also we will put 1 by root over 11, right? So here also 1 by root over 11, it will be whole square. Now what can we conclude? Now let us see this part. This part is where you have to do slight calculations. So I will take it as 1 by 11 equals to p square by q square, or I can also write that 11p square equals to q square. 11p square equals to q square. So from here, from this equation, I can conclude that 11 divides q. Please, if you see the difference, previously we were able to see 6 divides p, 5 divides p, but from here I can conclude that 11 divides q. So now let q equals to 11m. Let q equals to 11m. Now again we are going to put the value of q in equation 1. So I'll erase this part so that it becomes crystal clear to all of you. So we are taking that let q equals to 11m. Now putting the value of q in equation 1, you may write the statement putting the value of q in equation 1. What we will get? 11p square equals to 11m, and there is a whole square. So 11p square equals to 121m square. And from here we can write that p square equals to 11m. Let this be equation 2. From this equation 2 we can write that 11 divides p also. 11 divides p. So finally we can conclude that p and q, they have a common factor, that is 11. This contradicts that p and q have no common factor other than 1, or our final answer is 1 by root over 11 is an irrational number. So I hope that this is very easy for all of you, and we will move on to the next one. I think this was number 4. Okay, this was number 4 of my book which I am checking through a website. Okay, next is number 5. Now number 5 has got two parts. Prove that root over 2 is an irrational number. So then we have one more part to it. So I'll just change the question number, and I'll again change the question. Root 2 is an irrational number. Again the same thing. I'll just do a bit of editing. In my case, it is easy for me to edit, but for all of you, you have to write and do the sum. So I'm considering root 2 is a rational number. Again, change of statements will be there. I'll erase this part so that you will not have any confusion regarding what to edit and what not to edit, because you don't have to edit anything, you have to solve the sum. So now therefore root 2 equals to p by q, where p and q are integers and q not equal to 0. Now what we are going to do, if you remember the third step, I said remove the square root. So for removing the square root, what we have to do is squaring both sides. So if we square both sides, we will get root 2 whole square equals to p square by q square, or I can write 2 equals to p square by q square, or p square equals to 2q square. So from this equation I can conclude that 2 divides 2 divides p, right? Now let q let p equals to m. P equals to m. Now another statement, that is I did not write in the previous cases also, I'm just dictating it to you. That is putting the value of p in equation 1. If you put the value of p in equation 1, we will get 2m whole square equals to 2q square, or 4m square equals to 2q square. So we will get 2m square equals to q square. This is equation 2, and from this we can conclude that 2 divides q. So p and q have a common factor 2. This contradicts that p and q have no common factor other than 1. Other than 1, please rectify this, and therefore we can say root 2 is an irrational number. Now this was just the first part of the sum. There is a second part of the sum which we have to show. The second part, the question is show that 3 minus root 2 is an irrational number. Show that 3 minus root 2 is an irrational number. Is an irrational number. So this is the second part. I hope the first part is clear. Then I'm going to erase that, and then I'm going to show you the second part. Now we have already proved that root 2 is an irrational number. So you might be having a doubt in your mind that in the first part, since we are already proving that root 2 is an irrational number, then directly for the second part we can write that since root 2 is an irrational number, 3 minus root 2 is also irrational. But no, that is not the way it goes, because dear students, this question may come for 2 marks. 2 plus 2 4 marks you may consider, or 1 plus 2 3 marks you may consider. So this is not going to be that easy, or simply you cannot write the conclusion that since this part is irrational, this is also irrational. No, as you proved the first part to be an irrational, same way we are going to, I will not say the exact same way, it is a similar way and slightly different way, because we are considering two terms here. So it's slightly different way, but you, if you remember this way for rest of the sums in this exercise, it is going to be easy for you to prove other numbers as well, where you will find 2 or 3 terms with root overs in them. Okay, so now I'm going to start the second part. So let us consider that 3 minus root 2 equals to r. Now r is a variable that I am taking. You uh, the specific reason for taking r is that uh, um, I can write, let us consider 3 minus root 2 equals to r, where r is a rational number. So the reason for taking the variable r was that just it becomes easy for us to understand. R means we are considering this to be a rational number, right? So now 3 minus root 2, I am just writing this equation, 3 minus root 2 equals to r. R is a rational number. So if r is a, now I can write from here 3 minus r equals to root 2. Can I write the way we solve equations, that is linear equations? If you remember, root 2 goes that side, it becomes positive, r comes to the other side, it will be negative, right? Now 3, since r is a rational number, r is a rational number, implies that implies that 3 minus r is also a rational number, is also a rational number, right? Now if 3 minus r is a rational number, it should imply that root 2 is a rational number, because there is an equal to sign in between. So if 3 minus r is a rational number, root 2 is also a rational number, which this contradicts the fact that root 2 is irrational. Now if you just can turn the page of your copy, or if you have done it on the same page, you can see previously on the first part of the question we have already proved that root 2 is an irrational number. So we are getting 3 minus r to be root 2. Root 2 is already proved to be irrational, so obviously this is not rational, this is also irrational. So this is just a way of showcasing. As I said you before, that you can tell me root 2 is irrational, so you can write 3 minus root 2 is also irrational. But no, slight difference in expressing both the things is that I expressed it through an equation form, that is root 2 equals to 3 minus r. So if root 2 is irrational, that means 3 minus r is also irrational, right? So here I have shown root 2 is a rational number, which is obviously false because it is contradicting the fact that root 2 is irrational. You can write here already proved above, already proved, so, or therefore 3 minus root 2 is, from here you must write first that r is not a rational number, r is not a rational number, which implies that 3 minus root 2 irrational is irrational. Okay, you might skip this step, directly you can write that, obviously this is proving, because since root 2 is irrational, 3 minus r is irrational, or implies that 3 minus root 2 is irrational. So therefore 3 minus r is irrational, which also implies that 3 minus root 2 is irrational. So I hope this proof that is clear to you. The remaining sums, this was number 5, 6, 7, 8, as I saw the questions, it is similar to this, and same way we have to show. Okay, so I think we should move for number 6. Number 6 is again prove that root 3 is a rational number, and then show that 2 by 5, 2 root over 3 by 5 is an irrational number. So let's do it. And now I'm going to erase the full board, and I don't think the entire sum is going to fit on this one, but let's give it a try. So first part of the sum is telling root 3 is an irrational number. Let root 3 be a rational number. Okay, let root 3 be a rational number. So again, if root 3 is a rational number, we can express this in the form of P by Q, squaring both sides, we get root 3 whole square equals to P square by Q square, or or 3 equals to P square by Q square, which implies that 3Q square equals to P square, right? So from here we can say that, or it implies that, um, 3 divides P. 3 divides P. This is equation 1, right? Now let P equals to 3M. P equals to 3M. Putting the value of P in equation 1, we will get 3Q square equals to 3M square, or we will get 3Q square equals to 9M square. From here we can write Q square equals to 3M square. Implies that, let this be equation 2, implies that 3 divides 3 divides Q. So we can write P and Q have a common factor, have a common factor 3. This contradicts the fact, this contradicts the fact that P and Q have no common factor other than 1. Therefore, we can simply write root 3 is an irrational number. Root 3 is an irrational number. Now, this is just the first part of the sum. We will start on with the second part. It was that to show that 2 root 3 by 5 is an irrational number, is an irrational number, to prove. Okay, this is the second part of the sum. So if you remember the previous sum, number 5, we will take, let 2 root 3 by 5 equals to R, where R is a rational number, where R is assumed to be a rational number or considered to be a rational number. Okay, is a rational number. Now what I need to do is that whichever digit is having a root over before it, you isolate that digit. In the previous sum also we isolated, here also you isolate. Now isolate means what? You separate it out. That is equal to, here you see root over through root over 3 is there, so root over 3 equal to, so what will be root over 3 equal to? Here root over 3 will be equal to 5R by 2. Yes. Now from here I can say that since R is a rational number, it implies that 5R by 2 is also rational, is a rational number, which implies that root 3 is also rational. This contradicts the fact, because we have already proved here that root 3 is irrational, but here if I consider R to be rational, root 3 is becoming rational, which is false. So this contradicts root 3 is irrational. Please mention proved above. Proved above, for me it's proved aside, but for you it is proved above. Okay, therefore we can simply write 2 root 3 by 5 is an irrational number, I hope this sum is clear to all of you, and it is quite easy if you just remember the steps. That means what needs to be done, how it needs to be done. If you follow the process, if you remember the process, solving sum is a no big deal for rational and irrational this chapter. Some may say that root overs are there, it is very difficult, but not at all. Only if you take it in a positive way and take it in an easy way. So this was it for number 6. We have two more sums, and it is quite similar. It is quite similar. Um, so I will explain number 7, and number 8 is proof that the following numbers are irrational. Number 8 is similar to number 6, number 5. So I will not explain number 8. In case you are having doubt in any part of number 8, you can write and use the comment section. I'll do number 7 for all of you. And here also I can see I only need to edit a few things, because question is more or less similar. Question number 7, they are stating that to prove root 5 is an irrational number, and here they have asked minus 3 plus minus 3 plus 2 root 5. So excuse me. So minus 3 plus 2 root 5. So few things I need to edit, but in for you, you have to show it and do it in separately. Here I'll take root 5. Root 5 whole square becomes 5. Here 5. So we can write 5 divides p. So let p equals to 5m. This part of the sum we have already done in the previous sum. So is the same thing you need to repeat. So this equals to 5m square. We will get here 5, here 25, q square equals to 5m. So 5 divides q. They have a common factor 5, and here finally we can conclude root 5 is an irrational number. So this was for the first part. For the second part, for the second part, we have to take here minus 3 plus 2 root 5 equals to r. Now as I already told you, wherever whichever digit you will find that the root over sign is there, you have to isolate that digit. So here we have root over 5, so root over 5 equals to we have to do. So let us do it step by step so that it becomes easy for you to understand. First I will remove minus 3 over that side. So I'll get 2 root over 5 equals to r plus 3. Next step, root over 5 equals to r plus 3 by 2, right? Now as r is a rational number, so we can easily conclude that r plus 3 by 2 is also rational. R plus 3 by 2 is a rational. Then from there we can simply write root 5 is also rational. But this contradicts the fact that we have done here, that root 5 is irrational. So simply we can write that minus 3 plus 2 root 5 is an irrational number. I hope these sums are clear to all of you. If not, you can take the help of the comment section. Share your doubts. Please give constructive comments, and reach out to me anytime through the comment section. Thank you.